Okay, welcome back. This is a video just telling you how you should prepare for test 3 part 4. I'll give you the tips of every problems that you will find. In the first problem will use the idea of collisions of forces acting on a body, and this is what you have to understand. You have a elastic collision here. The object is moving with velocity v. It has momentum mv going to the right. After the collision, he has momentum mv, the same amount of momentum, but going to the left. Something has changed. So the momentum have changed. So initially the momentum was pi. Finally the momentum was pf. The change in momentum is here. So the force acting during the time makes a change in the momentum. And this is the change in the momentum. So you can see this change in momentum by writing the vector. If pi is mvx in the I direction, and the vector pf is minus mvx in the I direction, the change in the momentum, pf minus pi, is minus mvx minus mvx, minus 2 times mvx in the negative, 2 times mvx in the negative direction of I. Okay, this is the change in momentum, and the change in momentum is the force by the time acts, by the time that is acting the force. So you can solve this problem, for example, and get an idea what you will find. A ball of mass m, 5 kilograms, have an elastic collision with the wall. The ball is moving initially at a speed 2 meters per second, but this is the velocity because it's plus 2 meters per second, it's going to the right. And finally, he's moving with a speed 2 meters per second, but this is the velocity. It's minus 2 meters per second. It's 2 meters per second moving to the left, minus 2. If the wall exerts a force on the ball during the time 0.2 seconds, what is the average force? So this is the first problem, the first idea. There is a conceptual question also, and the problem 3 is based on the ballistic pendulum. So you need to understand conservation of momentum, and you need to understand this example that is here. This is the code, the barcode of the example. So the ballistic pendulum. So see the ballistic. So this problem is about rotational of an object that is rigid. So if it's rigid, means that the object, when he's rotating, is not being stretched or is not being compressed. There is no, the distance between any points in the object remain constant as the object is rotating. So this is the definition of a body that is rigid. So the distance between any 2 points, this distance remain constant as he is rotating. So the first things that you have to realize is that the change in the angle is the same for all points. Any points that you choose this point and this point, they will perform the same change in the angle. If you choose this point, it will perform. So delta theta is the same for all the points. Omega, because delta theta is the same, omega, that is delta theta divided by delta t, is also the same for all points. So it doesn't mean that omega is constant. It means that all the points have the same omega. Now, alpha is the change in omega respect to the time. So alpha is also the same for all points. Now, the acceleration tangential, this acceleration that makes the change, so this is the motion respect to this axis at the center. So if the velocity v increase, now is bigger velocity, there is tangential acceleration. This is the meaning of the tangential acceleration. There is a change, but in the tangent. So the tangential acceleration is related with the angular acceleration as at equal alpha by r. Let's go to put the r here in, not in capital letter like r. So it's clear that the tangential acceleration depends where you are. If you are here, for example, you will have a smaller velocity, and now when you are here, the velocity will be bigger because v is equal omega by r. So you are next to this axis, so you have a smaller velocity. If you are next to the axis, you have a smaller velocity, this compared with this. So the linear acceleration, the tangential acceleration depends on the radius. And the centripetal acceleration, that is v squared divided by r, or omega squared r squared divided by r, let's go to put here an r, and r is omega squared by r. So the centripetal acceleration depends on r because omega is the same for all the points. This question is asking you about omega for all points, a sub t for all points is the same a sub t for all points, is alpha, etc. So you need to review kinematics of motion. Problem 5 is about calculating the moment of inertia and understanding that the mass distribution of an object for rotation, it matters. And the mass distribution of an object is the amount of inertia that appear in the equations that is what it makes different to an object to rotate depending on the moment of inertia. If they have different moment of inertia, you can induce with the same torque, you can induce different angular acceleration. So remember that the sum of all the torque is the moment of inertia by alpha. So the angular acceleration is tau divided by I. So if the object have a bigger moment of inertia, the angular acceleration will be bigger. A smaller inertia, moment of inertia, will produce bigger angular acceleration. So the problem is they give you the structure of this object, they ask you what is the moment of inertia. And being aware that the moment of inertia is very important to calculate the angular acceleration. Go to the next problem. Next problem is about understanding kinematic equation of rotation. You know, I have done in class, for those who come to class, of course, that there is an analogy between rotational motion and translation motion. So the analogy is that x of t for a motion with constant acceleration is x0 plus v0 t plus 1/2 a t squared. So the analogy is that the x is the theta. The V is the omega and the A is the alpha. So you reproduce in a very easy way all the equation for a constant translational acceleration to constant angular acceleration. So you need to know this relation to solve problem 6. Problem 7 is about a yo-yo. The yo-yo is being solved in your example in two ways. Applying conservation of energy and applying the sum of all the torques equal I by alpha, that is this one. So it asks you, it's a similar problem as the yo-yo. Is not the yo-yo exactly, but it asks you to understand these things. Problem 8, it asks you how to calculate the torque, to realize that the torque is the force, the magnitude of the torque is the force by the perpendicular distance, or is the force perpendicular by the distance. The two ways are similar, so it asks you, for example, here, the torque respect to this point, the O. Okay, this force will not produce any torque because there is no perpendicular distance. This force, what torque will produce is the force by the perpendicular distance. So you see, I will draw a perpendicular line here, and it's the force, I can say, is the force perpendicular, this one is the force perpendicular by the distance. So it's this force perpendicular by the distance. So you calculate the torque, and you know that the torque now is counterclockwise, is negative. Now you do the same thing for this force, and you calculate again the torque for this force. Now this force, this one, will produce a positive torque, a clockwise torque. So you will count it as a positive. So it's the force by the perpendicular distance. So 8.5 by 0.35 is the torque, and it's positive. So this force has zero torque. This force has torque 14.6 sine of 40 degrees, because this is the amount of force that is here. 14 newtons, 14.6 multiplied by sine of 40 is the amount of force, and this amount of force multiplied by the radius, 0.3.5, will be the torque, but it will be a negative torque. So you will sum the sum of all the torques. So what I recommend you is try to solve this problem, this one, and this one. Be sure that you understand, and you will solve the problem that is on the test. And problem 9 and 10 is not yet defined, but probably it will need you to realize the conservation of angular momentum. Conservation of angular momentum say like this: the angular momentum of an object that is rotating with angular velocity omega